Hey guys! Welcome to Free Tutorial TV and Python tutorial for beginner. In this video, I'm going to give you a brief introduction about threads. So first of all, what is a thread? So our thread is an individual and separate unit of execution that is the part of our process. Now what is a process? A process is simply our running program. So for example, if you run a browser, it's a process. If you run a video game, it's a process. Now inside this process, multiple threads can work together to accomplish a common goal, and threads allows the program to run in. That is the single most important benefit of using threads. So let me give you an example. So when you play a video game, it has to handle few tasks. For example, it has to handle the graphics and the user interface. And if you are playing the multiplayer game, it has to handle the networking and all those things. It has to handle in parallel because it has to remain responsive at all times. So how does this video game handles those parallel tasks? A simple answer is threads. It can assign one thread for graphics, one thread for using interface, and other threads for networking. So by using threads, the video game can always remain responsive and it can run that task in a parallel way. Now let me explain threads using this diagram so you can see this whole blue box. Here is a process and the threads exists inside this process. So in this process you can see 3 threads. Now inside those threads you can see there is a code and local variable. So a thread is a lightweight process that exists inside the process. Also a thread is a sequence of control flow. That difference between that thread and the process is that the thread exists entirely inside the process and share its resources. So let's say inside this gray box we have the global variables that each thread will be able to share those global variables. And in addition, each thread can have its own local variables and its own control flow to work with those local and global variables. Now a single process may have multiple threads of execution, and as I already said that threads are useful when an application wants to perform many concurrent tasks on our shared data. Now let me give you one more example. So think about a browser. It has to handle the landing pages or the animations, or if you want to open multiple websites on different tabs and you want to run the video in one tab, and if you want to do another task in other tab, most of the time the browser always remains responsive and the browser can handle my tasks at the same time. So it uses thread to always remain responsive. Now there are 2 different kinds of thread. One is a kernel thread and other is a user space thread or a user thread. Now kernel threads are the art of operating system, while user space threads are not implemented in kernel. And the user space threads can be seen as an extension of function concepts in programming languages. Each processors have at least one thread, and that is the main thread. So if you don't even create a thread inside a process, it has at least one thread, and that is process itself. Now let's talk about the advantages of using threading. So the first advantage is the threaded programs can run faster on computer systems with multiple CPU use, because these threads can be truly concurrent on multiple CPU computer systems. The second one is the program can remain responsive to input at all the times. This is true both for single and multiple CPU computer systems. Now the third advantage is threading allows to do something as while a thread is waiting for I/O task or any other task to complete. So it always remains responsive. The next advantage is some programs are easy to express using congruency, which leads to elegant solution. And as a result they are easier to maintain and debug. So some programs or some processes are inherently concurrent in nature. And the next advantage is thread of process and share the memory of global variable. So as I have already shown you in the diagram previously, that multiple threads can share the memory of the global variables at the same time. So if a global variable is changed in one thread, this change is valid for all that threads. A thread can have local variables also, as we have seen in that diagram. Now let's talk about some of the issues or challenges you will face while programming threads for our program. The first challenge is the scheduling. So to execute a threaded program, it must rapidly switch between threads. So our program should be able to switch between threads efficiently and conveniently. The second issue or challenge is that resource sharing. So as I told you that multiple threads can share the same memory of the global variables. So since threads share this memory and other resources, it must be careful because operation performed in one thread could cause a problem in another thread. The next challenge you could face is of synchronizing of the threads, so threads often need to coordinate their actions, and as a software developer you may have heard about race condition of threads, which means the outcome depends on the order of thread execution, and often for synchronization we use locking primitives. Now that was the general description about threads. Now let's talk about the thread in Python. So in Python, our thread is an object like any other object that can hold data. This object can also be used to run. What method is the object also can be stored in the data structures, and this object can also be parsed as a parameter to method. Also in Python, our thread can also be executed as upper classes, and during the lifetime of a thread it can have various states. Now in Python there are two modules which support the usage of threads, and these two modules are thread model and threading modules. Now there is one thing to note here is that the thread module has been considered as deprecated for quite a long time. So often users are encouraged to use that threading model instead of that thread module. So if you will see in Python 3, that thread the module is directly not available, but indirectly you can use _thread to use the threads module. And this has to remain backward compatible with the previous versions of the Python. Now the difference between the thread model and the threading module is that the thread model treats the thread as a function, while the model threading is implemented in an object-oriented way. So in the next videos I will show you how to use these two modules in Python to create threads and handle threads in Python. I hope you have learned something new this time. I hope you have enjoyed this video. Please don't forget to like the video, share the video, and subscribe the channel. Have a nice day. See you in next video.